For our next speaker, actually two speakers, will be presenting consistent quality of service for Microsoft Lync across unified wired and wireless networks, leveraging SDN. So there will be our first speaker, Sarosh Vesuna, is the VP and General Manager of the Enterprise Networking business at Meru Networks. And previously, Sarosh was the business executive at Symbol, who spearheaded mergers and acquisitions in Wi-Fi, RFID, and security, and led several large joint partnerships, including a $150 million partnership with Intel that led to the development of the Centrino platform. He co-authored IEEE 802.11 protocol and co-founded the Wi-Fi Alliance, where he served on the board of directors. And our second speaker will be Ajay Malik, who is also in Meru Networks, author of the RTLS for Dummies and over 70 patents issued or pending. He's the Senior Vice President for Worldwide Engineering and Products at Meru Networks. He has been instrumental in crafting the vision of Meru SDN Wi-Fi, and prior to joining Meru, he has held leadership positions at HP Mobility Solutions, Cisco's Wireless Networking Group, and Motorola Wi-Fi division. Please welcome Sarosh and Ajay.
Thank you. Thank you very much. So good afternoon. And if my previous friend Kayur had to go right after coffee break, now it's time to kind of doze off. At least the coffee must have worn out. So this would be the time. Anyway, what we wanted to do is Ajay and I are from Meru Networks, as you heard. And just give you a quick overview of Meru. We actually do business in 22, or rather we have offices in 22 countries. We do business in 56. That is, we have customers, 13,000 of them. We are about 12 years old, public, and at about $100 million in revenue. One of the reasons we are here today is essentially we had focused our Wi-Fi on voice multimedia right from the beginning. And when we started looking at SDN, and especially once Ajay joined us, and he looked at SDN and said, this is the perfect environment to get certified with OpenFlow, and we are the first and only wireless vendor that has been certified on OpenFlow. It was a little bit tough because we were the first, so even the OpenFlow forum was trying to figure out how to test a wireless vendor, because almost everything else that tested was data center or wired vendors, et cetera. So with that, I just want Ajay to kind of maybe describe to us what is the challenge and how you want to solve it.
So, can you hear me? All right. So, good afternoon, everybody. So today, like some of the presentations that have gone through, they are a lot of my slides have become redundant, actually. A lot of the slides which Todd presented, right, the value of SDN, the unified communication, and across the unified wired wireless network. And I was like, OK, there goes my next slide. And now next slide. So I will just move forward and see, right, if it is really boring, then we will move way faster. All right. So let me see if this. Oh. This one?
The other one.
Other one. All right. So, so as you know, everything is becoming Wi-Fi, and Kayur at Aruba was talking about also, right? I think everybody here is connected Wi-Fi. I don't think there is any wire here, right? I hope not. So, in that scenario, but there is still a lot of wire. You know, you don't see it, but wire is very important part of it. You know, like even if the Wi-Fi is perfect, and everybody talks about like my Wi-Fi is best, you know, Meru, Aruba, Cisco, all companies will say that, right? But there is a wired angle behind it. And that is where the wired switches are there behind the APs, right? Or if the Microsoft Lync server is connected, it's connected to in the closet over the wires, and they are all connected over the wires, right? So even if you're trying to have the wireless experience and you have full mastery or control of it, experience is as good as the experience across the network. So like if somebody, right, you're talking a school, university, or anywhere, right? If somebody is running wired and they are doing BitTorrent on that switch, it's host, right? You don't get a good Wi-Fi experience, right? Or anything like that, right? If you want to control, you need both at the same time. So this is a typical network. Everybody knows in this room here, right? You have wired devices, wireless devices, and what you do is If you want to configure quality of service, you have to do CLI or scripts and configure each box, right? You can have good scripts, or you can buy everything from the same vendor so that you don't have to write multiple scripts, but you still have to do it, right? And if I tell you, hey, right, at 3 o'clock, there is a big webinar from the head of the organization, and everybody should have a seamless experience while viewing it. Now you have to make sure you do the time-based ACLs, QoS at every time, at every wireless device, wired device. You have to do it. This is how the world works, right? And if you see this, I think this is also a well-known diagram. Every switch or every router or every networking element, 3 layers: networking plane, the management plane, the control plane, and forwarding plane. Management plane is the CLI, web UI, how you interact with the box. The control plane is the protocols. And like Todd was mentioning today, every box knows what to do. Every box is intelligent. And that's a lot of intelligence in the control plane protocol. But there is nobody from the top who knows what's going on in the network, right? And the forwarding plane is whether ASICs or non-ASICs. It's software forwarding, packet in, packet out, which is programmed there. If you see this, right, this has been the traditional network, right? And where the SDN came is, actually, let me just go for a second around the history of SDN. How many people here know actually SDN history much? No? Okay, I can repeat this then. So in my mind, right, Gartner, how many people know Gartner? Have heard about Gartner? Good. So Gartner is very good, right? If you haven't heard about it, you should Google. They make good statements and a good analysis, right? And Gartner in 2012 said, like, you know what, if you buy wireless or wired, you must buy from the same vendor. If you are not buying from a vendor who gives you both, it's probably you will not have good control of the network. So that's pretty smart and I think pretty good move, right? Although in that process, some companies, including like Meru Networks, got booted out of their Magic Quadrant. They said, hey, Magic Quadrant is now a wired and wireless quadrant. So some companies who were doing only wireless, they started doing wired also, right? I don't know wired, but I will do wired because I need to be in the quadrant, or vice versa, right? So this was happening. And the reason was, hey, unified experience. Unified experience is so important. You cannot have control over only wireless or wired, okay? And at that time, 2012, when they did this, and they started the process in, I think, late 2011, SDN was not invented, per se, right? Well, SDN was there, right? In 2006, Martin Casado, right? They got bought by VMware, right? They did good work. They were creating a project. In 2008, the open flow concept started emerging there. Then SDN term was coined in 2010. It was not really like the guys who invented it called it. Somebody else said, oh, what you are doing is SDN. And it's pretty interesting story there, right? And then HP did good work, and NEC championed it, HP championed it, and I think they almost taught everybody what SDN is, and they put SDN in general vocabulary. A lot of push, and open networking forum was established, open networking summit started happening. People started talking about it. At that, NEC became the first wired open flow certified company, and actually we became the first wireless certified company for the open flow. And there was the reasoning behind it, right? The whole reasoning was, if you see, SDN, it creates an API. The whole idea of SDN is control plane is no more inside the device. You make the API outside, expose it, and there is a new software or running somewhere called SDN controller. A lot of people are making it. Open Daylight is one open source, very popular, right? There are a lot of commercial versions available. Cisco has 2 commercial versions. Juniper has it. A lot of companies have their SDN controllers out there now. And I hope Microsoft adds one also. It will be very useful for everybody to have a Microsoft version of SDN controller and make it easy for everybody. When they deploy the other systems, deploy it also. When you do this, what is happening is SDN controller is the big brother of the network. It's looking, and they are designed right, scalable, redundant, and all the good things which needs to happen. But in this model, what happens is the SDN controller has full control of all network. So when I send a packet to you or you send to somebody, there is somebody in SDN controller looking at all the packets and deciding, should I be allowed? And if it is allowed, what should be the quality of service, what priority, bandwidth, everything is decided by somebody else. So there is a central piece of software looking at the network as a big picture. When you do that, it makes the network very programmable, right? And this is the beauty. And what we did we enabled the same open flow in our wireless LAN controller. And then what happens is you get a network in which the wireless and wired both are visible using OpenFlow. So you can program the flows in the wireless side and the wired side. And that's the beauty. You know, like Keyur was talking about, like they started using Lync and Lync SDN API and integrating it. Ultimate goal is the same. You want to give full control so that when the Lync server, right, Microsoft did pretty good stuff. I think they also are visionary in that. When they created the APIs for SDN API, and they said, this will be the API, how you get notifications when the quality of service goes down, things like that. If those APIs notifications are happening, somebody should be able to use them. Somebody should be able to take an action. And I think this is the same theme around Nectar and BlueJeans and everything. It becomes useful, right? If you have that notifications. If those notifications are happening, and if there is an application running on the SDN controller, which takes action based on the applications and configures or provisions the whole network, then you do not have to have IT people running around or doing anything. You can have small applications just running and providing consistent quality of service. Or like the way Todd said, I think I'm going to use that term, service quality. That's a pretty good term, right? Because it's not just the quality of service, it's a lot of elements, right? QoS, when we see it's engineering term. Service quality tells much more. Is this making sense so far? Cool. So what it does is, it enables the unified wired wireless, right, by doing this. And it also makes it vendor agnostic. Does not matter whether you have the wired switches from HP, Cisco, Brocade, Juniper, Extreme, pick any company. You don't, right? In the hindsight now, right, once this has happened, I think probably for Gartner also it is, okay, you don't have to give both. If you do OpenFlow well, that's good enough. Because now you can play with everybody and still provide a good unified network. And that's what is our story. And you can have more applications there, right? And Todd was also mentioning today, it's all about apps. UC is just one of the app, which is going to add a lot of value in this space. And what we did is, we created one app. We call it Meru Collaborator. And I'll just skip this one. So we call it Meru Collaborator. And Meru Collaborator is the app which provides multiple things. It provides the consistent quality of service, predictable quality of service, gives you automatic control. It allows you to do debug and diagnose around the unified network. It was always a problem. Like Keyur was also saying, is it a problem in the wireless network or is it a problem in the wired network? And problem can happen anywhere. You know, we have deployed our switches, wireless controllers in many universities. Some universities still have 1,000 switches, and a lot of them. And you know, the bottleneck becomes the 1,000 switch. And they have other things happening in those networks, in the wired networks, and critical things happening. So the bottleneck shows up for many other reasons outside of wireless domain. But problems have to be discovered and auto-corrected, and that's where the Meru Collaborator does this. So Meru Collaborator is an application running on the SDN controller, and it listens to the Lync SDN API from the Microsoft Lync server, and whenever it needs to take an action, it automatically takes an action. It also provides good logs, call logs, views, topologies. You know, the topology always was visible as wireless topology or wired topology. Now you can see the end-to-end topology, the whole path, how the call flows, and then you can see, okay, the problem is not in this area, problem is only in this segment, and this is the root cause. So this becomes really powerful tool for the IT. And the beauty is, if somebody is OpenFlow enabled, it actually does not matter if they use Meru wireless or not, or whose Wi-Fi wired they use. It's a generic application which serves the purpose for everybody. And I think that is the beauty that SDN brings to the place. It's a generic application, standard application, can be used by anybody. Let me just, so this is one diagram to show like how the Meru Collaborator works at a bigger picture, right? You have the wireless network. Just for simplicity, I have shown this, but as I said in earlier example, there is always wire behind the wireless. You may be connected to AP, but there is a switch behind it, and the quality of service has to be maintained in that wired switch also. But just to show an example, if you have a wireless client and there is a wired client doing Microsoft Lync, right? You have Meru Collaborator running it and talking to the SDN controller, and then you have Microsoft Lync server running it. Just this combination is in my mind, very cool combination. That Lync SDN API and integrating with it and programming the network, it itself is so good, right? When we did our first demo and we were simulating and we were creating this, and now we actually deploy this in our building, like for our office, we call it customer zero for our building. And you do it and you feel the advantage of it. You can see that like call quality improved consistently throughout the building. People never complain about that, okay, there is an issue. And those are the things. And the issues happen not because of Lync, not because of wire or wireless. Issues happen for so many reasons. And wireless can be very unpredictable, right? Like Todd mentioned, right? I think over 60% calls are not good quality, and the reason is wireless, which is a good statement. But wireless is definitely a big reason, right? Like I had one call, some customer problem, and nothing to do, everything is same, but they did something, and it's very simple problems, right? Some wireless gets blocked for a reason which people don't know, don't see, and they think wireless quality is not working. Does that make sense, this whole Meru Collaborator? So these are some screenshots from the Meru Collaborator, right? We are in process of getting the demos out for like in merunetworks.com cloud demos, so people can see and play with it and feel it. I don't have the link. I can send the link later, and we can connect today or later after this, or at the dinner time or whenever tomorrow. But this is basically the whole topology. The whole idea is you can see the end-to-end path, and then you can see the action. Okay, this is the area where the problem is. This is the area there is a problem expected, right? Then we have the full visualization of traffic. You can see the traffic visualization, what's happening. This is also very useful to see what is the capacity need. You can see that, okay, my traffic has been increasing, my calls take this path, and this is where I have problem, and it needs to be fixed, right? And similarly, there are more sessions, more diagnostics in the application. It's a very generic application. It's like a web interface, simple application, which can enable good experience, right? Some more screenshots. And maybe I'll ask Sarosh, right? So Sarosh is also a founder of Wi-Fi Alliance, right? So just maybe a few comments around the value of SDN.
Yeah, so one of the things, obviously, anytime you do something new or something that's on the leading edge, the big question comes up as, so what's the business model? Are we really going to sell any of this stuff, or is this great for technologists to talk about? And obviously, once we saw what the value was, Ajay presented this Meru Collaborator for Microsoft Lync, but there are other things we are doing on location tracking, et cetera, which also benefit from SDN end-to-end visibility. So myself being the business guy, I have to take you back actually 15 years, exactly 15 years back, September of 1999. We were at Interop. 6 companies wanted to show off a new technology to the press, to analysts, and we had a room just about this size. And 1 hour before everyone was going to come into the room, the 6 companies had set up demos in the back together to show that their technology all worked together, okay? There was an infrastructure side, there were a network adapter side. That was 802.11, which became Wi-Fi. 1 hour before the analysts show up, everyone is sweating back there because no one is interoperable with anyone else, although everyone is conformant to 802.11. I mean, that's wonderful, right? Everyone's standards conformant, but nobody's adapter works with the other guy's access point. No one's access point works with the chipset from a different vendor. Some very basic things like that you take for granted today with Wi-Fi. Well, what used to be called the web key, now you got WPA2 and you got all that. One company interpreted the web key to be ASCII, the other interpreted it to be decimal numbers. They both said, the spec doesn't say it has to be one or the other. These were the little things, And yes, we showed the press, and what we showed the press was a lot of hand waving and pointing to each other's adapter and access points and shaking hands with competitors and saying, trust us, this will all work. The 6 of us at that point, Interop 1999 in Atlanta in September, made the decision that this will never take off if that's how we behave. We have to get together. We have to test this for interoperability. That was how the Wi-Fi Alliance was formed. It was actually called VECA because it stood for Wireless Ethernet Compatibility Alliance, because we all came from the Ethernet side. Engineers aren't very creative. And then ultimately we had to pick a real name for it. This could have been the Dragonfly Alliance, the Flank Speed Alliance, the Hornet Alliance, or the Wi-Fi Alliance. Those were the last 4 choices. Most of you only know it as the Wi-Fi Alliance. Why do I bring that up? Because once the Wi-Fi Alliance was formed, once the initial interoperability happened in early 2000s, and the Alliance said, we consider these 20 vendors interoperable, and then 200, and then 800, and whatever, it just got adopted. Everyone jumped onto the bandwagon. That's when Microsoft jumped onto the board. Amar, who couldn't be here, has been on the board pretty much since 2000. He's at the Wi-Fi Alliance, right, Pascal, in Berlin. So he's been on the board. He had been on the board with me. I only was on the board for 5 years. He's still on the board. Dell jumped on. Cisco jumped on. And last, Intel jumped on, because Intel wanted to make the chips. What I see as a parallel here that I wanted to point out to bring that example is, when we do these business cases and when we talk of technologies, there's a long time that the technology simmers because each company has their own version of what is conforming. And what I see now, or at least in the last 6 months, that's why we accelerated our development and productization and actually go to market, was the certifications are happening. There are organizations that are standing up and saying, if we certify this wired vendor and this well, we are the only wireless so far, but if we certify these components of the network, we guarantee that at least it'll work together. And that is why I'm very confident in the next 12 to 18 months, this is going to take off. And we at Meru feel confident that anyone that's doing voice, multimedia, unified communications, our wireless will be great.
Yep.
And questions, we got 1 minute.
Any questions?
Any questions, any comments, any thoughts? You think SDN will take off?
It's a, you know what?
Or you think it's a gimmick?
So I have heard this, right? SDN is a solution looking for problem, right? But I have heard this, right? People say that, but if you see, right, the unified wired wireless and the unified communication, those are really good problems, right? And I really believe that those are the 2 problems if SDN solves well, and which it can. It's not like a PowerPoint. We have actually working solutions now, right? Actually, we are releasing Meru Collaborator later this year.
So Ajay,
yes.
we didn't coordinate this last piece anyway, but since he just mentioned that some people think it's a gimmick, I want to tell you that in 1999, a very high-level person at the largest wired networking company thought that nobody ever would want to use wireless because it was so damn slow. 11 megabits, Ethernet is 100 going to gigabit, so on. Who the heck would want to go back to 10 megabits, 11 megabits? Yeah, question?
So, wireless networks do have some very challenging characteristics that we don't see on wired. One of those is burst loss.
Yes.
And many of the FEC techniques that we use can't handle burst loss, at least very well. So one of the questions I have is whether some of the issues that we see improved by SDN could in fact also be addressed by just having more robust FEC schemes that could better handle burst loss, or whether that's not the case.
No, you are right. So yes, things can be handled, but there is something which SDN enables, is handling the network in a holistic view. So you can improve the Wi-Fi, and I think Wi-Fi will improve, right? Actually, there are some announcements by Samsung and other companies. They are creating some new things to improve Wi-Fi. Like most of the traffic is TCP traffic, HTTP traffic on the web, right? And Wi-Fi is actually acknowledging everything too much, right? You can actually reduce some acknowledgement, improve performance many ways. 802.11ac new standard is for improving performance. I think Wi-Fi performance will continue to improve, but what SDN offers on top of it, as a holistic view and managing the network as a whole, you can't beat it. It is like, I think, one of the smartest idea happened in the industry, right? It really works.
Yeah, one more question. Yeah. Yes.
Hi, a nice presentation. So my question was like, so far, like I saw like Aruba, and I saw you like, I saw like the SDN implementation which you guys have done is more on the diagnostics. It's really good, but for the real-time, QS settings and like application side, like I mean, is there anything being done by?
So maybe my presentation was not that good then, because I do actually all dynamic quality of service, DSCP markings, everything automatically. Okay. Yes. So diagnostics is one important part, because diagnostics is the painful part. Okay. Because the problem is always like everything was working and why it's not working, and then the immediate problem is it the user error, is it the device, or is it the Wi-Fi? Nobody goes beyond that, right? And we need to, and since I am Wi-Fi company, so I need to make sure people know that it's not my problem, right? So that's why the diagnosis focus, but we do all automatic markings.
The whole policy stuff is actually what we do. After we heard Todd's kind of speech in the morning, and he kind of focused on the fact that, how do you diagnose all this? Yes. We kind of tilted it a little bit towards the diagnostics and removed some slides.
The only follow-up I have here is like for the policies, like I know like in the morning, I think Todd mentioned that it's still being standardized or investigated. So the implementation which is happening here, everybody is actually having their own implementation, or?
No, so actually this is the standard actually for the Lync side. I think 2.1 is the standard right now, right, Pascal? 2.1 is right?
Yes. It's released.
So it's released, and so you have to, like for the Microsoft Lync, there is a standard out there, and you use that API standard and adhere to that. So that makes it very easy, because Microsoft Lync has been ahead of the curve, right? But the northbound API from the SDN controllers, they are not standard today. And that has to be made standard. It will take time. So in fact, the way we wrote Meru Collaborator also, our application, we have written it with adapters. And what these adapters do, it can run on Open Daylight or other different SDN controllers. My time is up.
Time's up. And at dinner, if anyone wants to ask questions on anything, feel free. Thank you very much.
Thank you very much.